In this section, we are now going to start a new type of mathematical object called polynomials, and this is an introduction to what polynomials are. And you'll see that throughout this semester, where most of the stuff that we're going to do will deal with polynomials. They're really, really important in mathematics. You can find polynomials in almost every area of applied mathematics, at least. My introduction to polynomials starts with a little problem where you can assume that the bookstore sells pencils for students at school. And now it's going to adapt its price. So if there are a lot of students that want to buy pencils, well, the bookstore can afford to lower down its price. Its margin of profit will be not as large, but it can afford to have a smaller margin because it's going to sell more pencils and pens. Sorry, because this is what I drew. I drew a pen, not a pencil, and you could think that similarly, if not that many students want to buy pens, then maybe to still make a bit of profit, the bookstore is going to want to rise the unit price for every pen that it sells. So we're going to assume the following thing. Okay, we're going to assume that the bookstore thinks that it can sell 100 units at $2 each. Okay, in this way they're not losing money and they're making a reasonable profit. Okay, so I'm going to write this up. Here we go. I'm also going to assume something. We're going to assume that if we sell 10 more units, we can lower down our price by 10 cents. But the other way around is true as well. So if we sell less units, if we sell 10 less units, then the unit price will go up by 10 cents. So let's write this up. Okay, so to illustrate this, I'm gonna put some numbers in a table. So imagine D is demand, P is the unit price. Okay. So we know that if the demand is 100 units, we can sell them at a unit price of $2 each. But according to my next rule, if the demand goes, for example, if it goes up by 10 units, the price goes down by 10 cents. So I'd be selling them at $1.90. If it goes up 10 more, I'd be selling them at $1.80. It goes down by 10 cents each time. Similarly, if the demand goes down by 10, price is going to go up by 10 cents. Like that. Now, what I'd like to find is an easy relationship between numbers on the left and numbers on the right, demand and price. So, for example, I could write here something like if it's 100, to which I add a multiple of 10. You can think of x for now as an integer, but it doesn't have to be. Okay, if it's equal to 1, if x is equal to 1, you would get 110. If x is equal to 2, you'd get 120. This is x equals 0, x equals 1, x equals 2. This would be x equals what? Minus 1. This is x equals minus 2. So with that x, I can generate numbers in the left column. So what would be for each value of x, what would be the corresponding expression to generate values that I find in the right column? So in other words, what would be a related expression, okay, over here that would generate for those same x's the numbers 2, 1.9, 1.8, 2.1, 2.2. So I want, for example, when x is 0 to generate the number 2. When x is 1, I want to generate the number 1.9, and so on. So think about this for a second and pause the video and come back. Okay. So what is the expression that I need? Well, when x is 100, unit price is 2. So if I write, you see that the expression I'm looking for is going to be something like this. Something 2 plus something times x. When x is 0, I get 2, you see. When x is 1, however, I want to get 1.9. But when x is minus 1, I want to get 2.10. So what would I replace the my constant by here? Well, as you can see, it has to be equal to minus 0.1. You can check if x is 0, yes, it's 2. If x is 1, 2 minus 0.1, I get 1.9. If x is 2, 2 minus 0.1 times 2, that's 1.8. Okay, so I'm able to generate all these with the same x's that I have here. Okay, so this expression here goes with this one, the one on the left here. So when the demand is 100 plus 10x, the price is 2 minus 0.1x. Okay, and with this, what I'd like to do is add up a third column, which are the revenues. Okay, which I'll call R. What are my revenues? Revenues is what? It's if I sell 100 pens at a price of $2, what are my revenues? Well, it's easy, right? It's 200. How did you get that? We just multiplied them together. So revenues is demand times unit price. Same here. 110 times the unit price gives me my revenues. So overall, what are my revenues here in general? Well, I need to multiply this expression, 100 plus 10x, times 2 minus 0.1x. And that gives me my revenue function. Now I'm going to rewrite this expression differently using the distributive property. So remember, if I have something like this, a times b plus c, it's the same as ab plus ac. So I'm going to use that distributive property twice to multiply these two expressions. So first of all, think of this as your a. This is b plus c. Actually, it's if you put a minus, this is a minus here. So you can think of this as b minus c. So this is going to be a times b minus a times c. And I'm going to use that again. So now this is like my so of course I can write b plus c times a. That's also ab plus ac. So now this is my a, and this is b plus c. So this is going to be using the distributive property a. So 2 times 100 plus 2 times 10x. And over here, it's going to be minus 0.1x times 100 minus 0.1x times 10x. So finally, I get what? I get 200 plus 20x minus 0.1 times 100, that's 10. And 0.1 times 10, that's x. But there are two x's, right? X times x is x squared. So finally, I can regroup like terms. I've got 20x, I've got 10x, so that's 200 plus 10x minus x squared. And that's my, what do we call my revenue according to what x is. So let's check that it works. So for example, when x is 1, this is going to give you $209 if you calculate this. Well, let's check that it works with my expression. If I let x be, so what value of x will generate 110 and 190. Well, it's right here. It's x equals 1. So if I replace x by 1, let's just check that it works. Let's x be 1. I should be getting 209. R is going to be 200 plus 10 times 1 minus 1 squared. So what is that? That's 200 plus 10 minus 1. So that's 200 plus 9, 209. Bingo. So it works. The value I have here matches up this value. So it's a way to check that my expression is correct. So what I have here is an expression that gives me my revenue. We call this expression 200 plus 10x minus x squared a polynomial. So a polynomial is going to be a sum or subtraction of powers of x that are potentially multiplied by constants. I can add and subtract polynomials. So for example, if I've got two polynomials, so this is the first one, and I want to subtract to it the polynomial 3x squared, so I can put those in brackets if you want, so that you can see I've got two of them. So this is a polynomial minus another one. I can add them up by regrouping like terms. First thing maybe is to distribute this minus sign. So this is minus 3x squared minus 6x plus 4. Now I've got a list of powers of x multiplied potentially by constants that are added up or subtracted. So I'm going to match up like terms. So what you want to do is you match up similar powers of x. So I've got x cubed here. I don't have any other ones. So this is 4x cubed. After that, I've got a minus 3x squared. That's also on its own. And then I've got minus 2x, minus 6x. Those I can match. So, So this is minus 8x. And finally, I've got constants that I can match up. So minus 8 plus 4 is minus 4. And I end up with another polynomial that's simpler. It was obtained by subtracting the previous two, and I get another one. So essentially, when you add or subtract polynomials, you end up with another polynomial.